Hello friends, let us study about validation activities. Validation activities consist of starting from unit test. Let me read out and we'll explain one by one. Unit testing, integration testing, functional testing, system testing, and in the end is acceptance testing. Now let us study about unit testing. Now unit testing refers to the testing program units in isolation. That means your a small one module is tested. Unit means one single, so one module is tested. There are two reasons for testing a unit in a standalone manner. That is, separately one unit is tested. You can test this unit test also. This you can perform with the help of tool. Now, the first thing is the error found during testing can be attributed to specific unit so that this can be easily fixed. Now, for example, if there is a module for my code, there is a module A, module B, module C, module D. Four modules are there. Now, when I'm performing unit test on module A, if there is any error generated, any fault generated, so that is generated from module A, so that can be fixed. Now, what happens in second point C? During unit testing, it is desirable to verify that each distinct execution of program unit produces the expected result. Yes. Now, as I was talking now, I'll talk, as I'm talking about the four module, I'll consider this four module example throughout the testing process, the validation activities. Now, as I was talking about the four modules, so I know what could be the four modules expected output. So this can be easily executed. When I test one module, one after the other, once I finish with module A, I'll test with module B, and I know what would be the output of module B. Same with C and D. Now, what happens C? Now, the defects found in unit testing are internal to the software development group and are not reported to the personal hierarchy to be counted in quality measurement matrix. Now, see, the defects which are rising up, the defects which comes up, which are encountered, these are referred to the quality assurance team that yes, the defect has been encountered. Now again, this defect reported makes your test report. This goes to the development team, and development team studies and then find out where was the defect and try to fix. That means its quality is little bit uh, not downgraded actually, but it's little bit low, or it's compared to the qualities given like availability, reliability, and so the according to the values of threshold, the qualities have been compared. So, yes, the defects which are found in unit testing are not reported because they have been solved internally. Now, since there are two types of unit testing, that is static unit testing and dynamic. Let us see what is a static unit testing. That is, the code of each unit is validated against the requirement of the unit by viewing the code. Now, I hope you remember our white box testing, and the white box testing we studied about the static testing. Now, static testing was also one of the unit testing which the four methods were used, like desk checking, informal review, and the reviews and all. So, in those process, that was a manually done so that any defects or any errors could generate, they could easily solve out, and author could resolve with some of the answers. So, code review is one of the component of defect minimization process because by looking at the code, by making an error guess, since you are experienced one, you started your programming from the first year, so now you are experiencing. After seeing a program, you can easily say what is the error, what could be the defect. The same way, the people who are working on the unit test are also experienced ones. So they make some not error guesses, but with the help of the review process, they go through it, and if they found there is a defect, if there is an error, they easily communicate, and that could be easily resolved and help to detect problems, so that minimizes the detection problem and defect could be resolved successfully. But in dynamic testing, each and every that isolation process, the individual component or a module is isolated and it's tested. so that its actual input, actual output, and expected output are measured. So dynamic unit testing means the testing actually executed by running means it's executed. You make a test script by processing of test script also by executing it also. So it may be noted that static testing unit is not an alternate to the dynamic testing unit. Of course, in dynamic unit testing, you try to execute that. You try to run a code. Whereas in in a static, you are not executing. What are you doing is you are reviewing the code in the process that the panel comes, you give them the distribute the handouts. After distribution, they are prepared. Yes, they prepared for a while. You take a minute, then there is an author. The procedure itself is so lengthy that the dynamics solve rapidly. A programmer a programmer performs both kind of tests. That means it can do the static testing as well as dynamic testing. Now, once you studied the static testing and dynamic testing, we'll go for next is system integration testing. Now, system integration testing means here integration like two modules or three modules or a component. Module can refer to as a component. Now, two or three modules can be tested. So now what happens is the unit is only one. The modules, the first code, a small program code. That module is itself isolated. Now here the modules have a well-defined interfaces with other modules. That means module 1, module 2 and module 3. These three are taken together and put it into the execution unit. Now when executed, if that error comes up, if defect comes up, try to solve that defect. Because when three modules are executed together, the actual and expected outcomes are compared. Now let us see what is that. This I just overall I explain you now. Let us read about. A module can be a subroutine of function of procedure class or a collection of what the module I'm talking about. The module can be a subroutine, a routine, a function, procedure, or a class or a collection of those basic elements that put together to deliver a high level service. Okay. So that means one module to three function 1, function 2, function 3. These three functions I'm putting into the into the test. I'm evaluating test on them to just see whether the defect is right or not. So a system, the entire system is a collection of a module interconnected in a certain way. Either it's an object oriented way, they are connected in a class. A class is what that group together. So they have a number of functions. The member functions, they can be made private or public. I hope you know this object oriented functions. So they have Java, C++. Now, the next is the importance of integration testing is for three reasons. They are outlined for three reasons. The first is different models are generally created by a group of different developers. Yes, see the module 1. The module 1 is created by team A. The team A consists of at least 5 people. Now then module 2. Remember about your RAD model, rapid application development. So how the RAD model works? The RAD model is like the one code is given to them, the other code, the not code entirely, the one module is given to team A, other module is given to team B, the third module is given to team C. Now when the module is finished developing, now the time is to execute, to club these three modules. So when they integrate, errors come up, you try to solve it. The developers may be working at different sites. Yes, one is working in different sites means in different region, in Bombay, in Pune, in Bangalore. And now when I call them that please give me your codes, let me see the execution as a project manager, as a team leader, sorry, not project manager, as a team leader. So team A, team B, team C handed me those three modules. Now it's time for me to execute it, to check it. So interface error between there would be the interface error when the three modules are together combined together because all the three has done by the different teams, different developers team, I must say, not team, not the developer, that I must say developer team has done these three modules. Now Second, unit testing of individual model is carried out controlled environment by using test scripts and steps. Now, steps are dummy models which merely return predefined values. Now they are defined as now since again they are being tested as a unit test. They are put on the test of unit test once again, and they're treated as stubs and drivers. That means the original program remain as it is. The drivers and stubs are created from them so that when they are put into executions, we could see that expected and actual values. If a module under test, unit test invokes several other modules. Now, three, some modules are more prone to errors than the other modules. Now, when these modules are tested, I found that module A is giving me lots of errors, then module B is giving me lots of errors, and so on. So it is essential to identify the one causing the most failure. Now I want to see while integrating these three modules, which module is causing lots of defects, lots of errors, or lots of failures. Which model is causing faults? So, how these modules are created, like different types of interface. For the interface, with the help of procedure call interface or shared memory interface or message passing interface. So now what happens is while putting them together, we see one is construction, the following error in the construction, the entire piece, inadequate functionality, location functionality, changes in functionality, added a functionality, and misuse of interface. Misunderstanding of interface. When one module is interfaced to another, we saw the three ways. It can lead to misunderstanding that this module is used for adding and are used for different purpose. Data abstraction, alteration, addition to error processing, and so on, and initialization to different values. Then the system integration technique is divided into two types. We have incremental, top down, bottom up, sandwich, big bang. Now, incremental testing is that means the number of system integration test cycles and total integration times are determined by the following parameters. So, incremental, that is that entire thing, like from how your development generates that iterative process. The number of modules in the system, relative complexity of the modules, and the relative complexity of the interfaces between the modules. Now, focus on the complexity. Always remember of optimization. That means your complexity should be very low, not so high because that will cost your company. Number of modules needed to be clustered together in each test cycle. Now you have to decide how many modules should be put into the test. Clustered together and should be tested together in each test cycle. Whether the modules to be integrated have been adequately tested before as a component one, then turnaround time from test, debug, fix cycle. Now when you test, then you debug, then you fix the code, how much time it took, the turnaround time, the threshold time, so all those things. All those matters because that counts your quality. The quality assurance team will accordingly generate the quality, will label you which quality level the product is achieving. Now, next is top-down approach. Now you just see how the component uh, are placed. The boxes you see are the component 1, the component 2, component 3, component 1 till component 7 it is generated. Now how they are interfacing? Now their interfacing is top down. So how their interface? Now since my table is at the next slide, what we'll do is we'll just read out. So one is interface with two step 1. Now step 2 is one is interface with 3. Step 3 is one is interface with 4. Now at the step 5, how much is the step? Step Okay, step 3. Now step 4 is 1, 2, 5. Let us see. Yes. Step 5 is 1, 3, 6. Then next step is 1, 4, 7. So see how the top down approach is conducted. Now second is bottom up. Now bottom up is from 1, 4. Bottom up integration is just the opposite of a top down integration. Now here the components of new product development becomes available but in a reverse order. Now double arrow denotes both the logical flow of a components and the integration approach. So don't bother about that. Then the navigation is done from the bottom up. That is 1, 4. First step 1, step 2, 2, 5, step 3, 3, 6. Then 1. What was the next step? Wait, step 3. Okay, step 4. Now step 4 is 1, 4, 7. Next step is 2, 5, 7. Next is 3, 6, 7. Correct. And in the end, the entire thing, the 1, 4, 7, 2, 5, 7, and 3, 6, 7. See how this written. The same way it was top down. Now, how how useful it is, or see, the interactive and agile model is an example to explain in a different path or a logical flow. So it is easy to say that top-down integration approach is best suited for the waterfall model and V model, but the top bottom-up approach is for iterative and agile methodologies because agile comes from the bottom up. Then you have a sandwich and big bang. In a sandwich approach, a system is integrated by using a top-down and bottom-up, both the mixture caliber. So its hierarchical is form, consisting of 3 layers. The bottom layer consists of all modules that are invoked. They are called up. And bottom-up approach is applied to integrate the modules in the bottom layer. The top layer modules implements major design decisions and they are integrated by using the top-down approach. So in a Big Bang approach, the first all the models are tested individually. Yes, they have to individually test together, not together but individually. Next, all these models are put together to construct the entire system, which tested them as whole. The whole system is tested. So sometimes developer use this Big Bang approach to integrate the small system. Now here we stop. Here I stop the integration testing. Next time we'll see the function testing. Till then, enjoy your unit and integration testing. Try to do with your small code. Till then,